Can you hear me? Hello? Okay, my voice is clear to you all? Okay, let me present my screen to you all. My screen is visible? Hello? My screen is visible to you all? Okay. Okay, so just wait. Okay, so see, up till now, see, I'm not repeating once again, but the ECC topic in the elliptical curve cryptography, right? The first chapter, the first point that we have discussed, that is how to generate the points, right? So for that, this particular algorithm, how to see one particular, you can say that in this way. Just wait, I will show you. In exam also this type of question can be asked, that is this type of EPAB, that means you can say that this type of equation is E1311, right? A and B that is given to you. You have to use this equation and you have to generate the points, right? So this thing that I have explained in your first lecture, how to generate the points. Okay, so I am not repeating that thing. So that concept that I have discussed. Now then, after in next class, right? So in the second lecture, what I have discussed, that is the operation over E, operation over the elliptic curve, that I have discussed. So again, I am not repeating. So in that, what I have discussed, that is the operator is plus. So here you can say that the operation is the addition of, let's say, the 2 points on a curve are given, right? So the first point, that is, you can say that x1 y1, and the other point, that is x2 y2. So here the operation is a plus. So the addition of 2 points on the curve. So when you perform the addition operation, then you get the another point on curve, right? So in that, the three cases that I discussed, that is, see, these are the three scenario. All of you know that, and based on that, some of the example that I have covered in last class, the three scenario that you have to remember. See, this is the first one, that is the P is not equals to Q, right? So that means the X and Y coordinates are different in P and Q. Okay, so at that time, you have to remember this formula. If P is not equals to Q, then which lambda you have to use for that equation? This lambda. Lambda means, see, here in that case, you have to use x3, that is equals to lambda square minus x1 minus x2 mod P, and y3, that is equals to lambda in bracket x1 minus x3 minus y1 mod P, right? That you have to use, where lambda is what? That is y2 minus y1 divided by x2 minus x1. So in this way, this is the first case that I have discussed. You have to remember that. The second scenario that I have discussed, that is P equals to Q. And when P equals to Q, so at that time, which lambda that you have to use? You have to remember this formula. For lambda, it is 3x1 square plus a divided by 2y1. So this lambda that you have to use. And what about how to calculate the x3? Basically, the purpose is to find out the another point on a curve, right? The 2 points are given. Okay, P and Q means x1 y1 and x2 y2 coordinates are given to you, and you have to find x3 y3. So in get the first scenario that I have discussed, where the P is not equals to Q. So when P is not equals to Q, so at that time the X3 and Y3 that is calculated by using this formula, and while lambda that is Y2 minus Y1 divided by X2 minus X1. And the second scenario, that is if P equals to Q, so at that time how to calculate the lambda, that is 3x1 square plus a divided by 2y1. Okay, and where how to calculate the x3 and y3? So x3 that is lambda square minus x1 minus x2. So that is equals to, here you can say that because the both the points are same, and that's why lambda square minus 2x1, and y3 that is equals to lambda x1 minus x2 in bracket x1 minus x3 minus y1. So these are the two formula that you have to remember, right, that I have discussed. And the third, that is this thing that I have discussed, that is the points are additive inverse of each other, right? If here in this scenario P equals to x1 x2, then the Q equals to x1 minus x1 comma minus y1, that is Q equals to minus P. Okay, so these are the three cases that I have discussed in last class. So is there any doubt in these three cases, everyone? Please let me know. Please write down in the chat window. Can I explain you an example based on that? I think one example that I have discussed in last class. So again, I am repeating that thing so you can understand. So is it clear to you all up to this? Is there any doubt? Please reply. Okay, so I think all are clear. Okay, so now next move to the next topic, the third class. So now see this concept, I think one example that I have discussed, again I am repeating that thing. So again this type, see one of the question can be asked in exam, that is, see for elliptic curve the value of A and B is given. You have to use the elliptic curve equation, and based on that you have to generate the points. Okay, this is the one type of question can be asked in exam. The second type of question, that is operation on elliptic curve. That means the 2 points x1, y1 and x2, y2 is given to you, and R means basically you have to find the another point on a curve. So that you have to find. Okay, so now P equals to 4, 2 is this x1, this x2, this y1 and this y2, and the prime, that is P, that is the prime value, that is 13 given. Okay, now R equals to P plus Q means you have to find another point on a curve. Okay, that is x3, y3 that you want to find. Now the three cases, all of you know that what is the first case? So here you observe that the P is not equals to Q, means x1 means both all the values are x1, x2 and y1, y2 are different, right? So P is not equals to Q, then all of you know that the case 1 will be applied. So now see, when case 1 will be applied, then which equation you have to use? See here. When this case is used, so at that time how to find the another point x3, y3? So the x3 is calculated by lambda square minus x1 minus x2 mod P, and y3 is calculated by lambda in bracket x1 minus x3 minus y1 mod P, and where lambda that is equals to y2 minus y1 divided by x2 minus x1. Okay, so now see here in this case P is not equals to Q. So first the lambda is calculated. So lambda that is equals to y2 minus y1 x2 minus x1. So what is y2? So y2 that is 6 minus 2 divided by 10 minus 4 mod 13. So what you get here? So you get here 4 by 6 mod 13. So can you write in this way? 4 multiplied with 6 inverse mod 13 mod 13, right? So now see here I have to find the inverse with respect to mod 13, and all of you know the multiplicative inverse extended by using extended Euclidean, right? So when I calculate it, so what I get the value 6 inverse mod 13, that is that I am getting, that is 11. Okay, so now here I can say that it is 44 mod 13. So what I get 5. So means lambda I am getting. Now once I am getting lambda, so I am using this formula x3 that is equals to lambda square minus x1 minus x2 mod prime, right? So lambda that is 25 minus What is the value of x1? So the x1 that is 4 and x2 that is 10. Okay, so all this value that you have to put here. Okay, so when you put, so what you get? x3 equals to 11. And what is my equation for y3? y3 equals to lambda in bracket x1 minus x3 minus y1 mod prime. Right? So now put all the values here over here. Okay, so now finally what I'm getting, this is minus 37 more 13. So now here when I'm calculating it, what I'm getting 2. So that means r equals to x3. So x3 that I'm getting, that is 11, and y3 that I'm getting, that is 2. So that means what is the meaning of it? So when the 2 points on a curve x1 y1 and x2 y2 is given, and when I'm performing the operation, means plus operation, right, on this 2 points, so I'm getting another point on a curve, and that is x3 y3. So all of you clear up to this? Is it clear to you all? Is there any doubt in this example? Hello? Please communicate with me, everyone. How can I understand whether you are getting or not? Only Abhi is answer me. Abhi is only attending my lecture, right? I want the answer from everyone so I can understand. Now, see the second scenario, everyone. So now this E13, and then there is a value of A and there is a value of B. Okay, so the curve is given to you. Okay, this elliptic curve is given to you, everyone. Now, the point that is P equals to 1, 4. Okay, the point is given. Now, the question is find 2P. So basically, 2P means what? P plus P. 2P means P plus P. So here means here which scenario, why case number 2 is used? Why case 2 is used? Can you write down in chat window? Why case number? Yes, because P equals to Q. Right. So here P equals to Q, and just okay. So listen here in this case. So P equals to Q. That means case 2 can be applied. Right. Now how to calculate the lambda? So for lambda, this equation that you have to use here. So for lambda, so for lambda this equation that you have to use, that is lambda that is equals to 3x1 square plus a divided by 2y1. Okay. So when you are using that, so when put the value, so what you get, everyone? So x1 that is one value. A means here the curve value is given. A is 1 and B is 1. So A I am putting 1 over here. 2 into multiply with 4, right? So what I'm getting here, so 4 multiply with 8 inverse mod 13, right? So what I get, lambda equals to 7. Lambda equals to 7 that I am getting. Now, once I am getting lambda, so all of you know that after getting this lambda, how to calculate when P equals to Q. So at that time, for x3, how to calculate the x3? X3 that is equals to lambda square minus 2x1. Okay. See, otherwise the x3 y3, the formula remains same, but here the x1 and x2 that is equal, right? So that means here it becomes lambda square minus 2x1. Okay. So the x3 is calculated by using this formula, lambda square minus x1 minus x2, right? Because both are same, right? So that's why what I'm getting x3 is 8 and y3 that is lambda in bracket x1 minus x3 minus y1 mod prime, right? So when I put the value over here, so what I'm getting 12, right? So that means here I can say that 2p that is equals to p plus p that is equals to x3 y3, and so what I'm getting the value 812. Okay. Now all of you from the example number 2, now all of you know the value of this 2p that is 812. Now all of you find out the 4p, find 4p, calculate it and quickly tell me the answer. Please write down this. Please write down this E1311. So the curve that is E1311 where the value of A is 1 and the value of B is 1. Okay, so quickly write down in your notebook. And also write down this thing. I want to calculate 4p and what I am getting the value for 2p that is 812, right? For 2p what I am getting 812. Now calculate the 4p everyone and tell me the answer. For 4p what you have to do? Please write down in the chat window what you have to do. 3p plus p. Abhi, have you calculated 3p? Right now you have calculated 2p, right? So if you want to calculate 4p, then what do you have to do, Abhi? 2p plus 2p. That operation can you perform? Right? Yes, Janil, you are correct. So that means please calculate it. So now which case is used? Case 1 or case 2? If you are calculating 4p, so for that if you are using 2p plus 2p, yes, case number 2 is used, right? Now all of you know the case number. See, I am opening, I will open that equation. Okay, so quickly do it everyone. This is the equation for lambda. Okay, this is the equation for lambda, this is the equation of x3 and this is the equation of y3. So quickly calculate it and tell me the answer. What is the value of lambda, what is the value of x3 and what is the value of y3? I want answer from everyone. Quickly do it. I will give you a time. Is it done, everyone? Is it done? Yes, so what is the value of lambda? Please write down in the chat window, everyone. Can you hear me? Hello? Can you hear me, everyone? What will be the value of lambda? Keval, Abhi, Janil, Prince. What about the other students? What is the value of lambda? Please reply. See, if you are not answering me, how can I communicate with you, everyone? Can I skip the topic, everyone? So please communicate with me. So it's a practice for you. This type of example can be asked in exam. That's why it's a practice for you, right? But in online, you are not communicating with me. So how can I communicate? Please communicate with faculty, everyone. Okay, fine. If you don't want to reply, it's fine. Okay. Okay, so listen everyone. Here I have calculated 2p, that is 812. Right now the question like this, 2p, that is 812. Okay, from this example you are getting. Now the question is find 4p. So if directly this type of question is asked, that is this type of curve is given to you and the point is given. Now my question is find 4p. Okay, so first of all, if the point is given, first of all you have to calculate 2p. Okay, by using this equation. And once you get the 2p, then you can calculate the 4p by using this formula, 4p, that is equals to 2p plus 2p. Okay, so see, this time I will not provide you a material, right? So do by yourself, everyone. So 4p, that is equals to 2p plus 2p. So all of you know that the case number 2 can be applied. And when the case number 2 is applied, so what is the formula for lambda? Lambda, that is equals to 3x1 square plus a divide by 2y1, right? So what is the value of x1? The value of x1, that is, all of you know that, that is 8, and a, that is 1, is given, divide by 2 into y1 is 12. So when you put all the values, and so here you have to find the inverse, multiplicative inverse method that you have to apply. So after that, the lambda that you are getting, that is 1. Now then after the which formula, x3, that is equals to lambda square minus x1 minus x2. This formula that you have to use. Okay, so when you put all the values, so what you are getting here, 11. And y3, that is equals to lambda in bracket x1 minus x3 minus y1 mod prime. So again, when you put all the values, so here you are getting 11. So here I can say that the 4p, that is equals to 11, 11 I am getting for, okay. So now once you get this thing, right, the same curve is given, same point is given to you as earlier. Now the question is find 3p. Okay, so now all of you know that what is the value of 2p? 2p, that is for the same point, the 2p, that is equals to 812 that you are getting. So now here, if you want to calculate 3p, then what you have to do now? 3p equals to 2p plus p. Okay, so now all of you know that here the p and q are different, so that's why the case number 1 is applied. And when case number 1 is applied, how to calculate the lambda? Lambda that is calculated by using y2 minus y1 divided by x2 minus x1. Okay, so based on that you have to calculate. So lambda you are getting that is 3, x3 by using this formula when you calculate 0, and y3 what I am getting 12. So the meaning here is that the value of 3p is what? 0, 12. Okay, so now the next example is given to you. Now p equals to 8, 1 is given to you. Okay, so all of you know that here in this case, on the case number 2 that you have to use, x3 and y3 is calculated. So here what you get, the see here in this case example number 5, what the example number 5 says. So here in this particular case, the point that is p equals to 1, 4 that you have taken, the curve is this curve you have taken. Now we want to calculate 2p, 3p. Now earlier all of you know that 2p, that already for the same point, for the same this p equals to 1, 4, same point I have calculated 2p, right? Now what is the example number 5? So here the same curve is used, but now instead of this p equals to 1 comma 4 point, now I'm taking the another point. Now I am considering the what? Another point. Okay, so now here, now the question is calculate the 3p. Okay, calculate 3p. So now here what happened? First of all, if you want to calculate 3p, so for that first of all you have to calculate the 2p. Okay, so for this particular point, first you have to calculate 2p. So all of you know that here the lambda you can calculate by using this equation. Okay, now x3, when you calculate x3, what you get? 11, y3 what you get? 2. Okay, so 2p equals to x3 comma y3 means 11 comma 2 that you are getting. So this is the 2p value that you are getting. Okay, so now once you get 2p, so what I am doing? So now 2p plus p, so then I am getting 3p. Basically my purpose is to find 3p. So first what I'm doing, first I'm applying the case number 2 and first I'm calculating 2p. Now once I get the 2p value, then after what I'm doing here, 2p plus p. So now here I can say that p is not equals to q, that means the case number 1 is applied. And when case number 1 is applied, all of you know that the lambda is calculated by using y2 minus y1 divided by x2 minus x1. Up to this clear everyone? Is there any doubt? Is there any doubt everyone? All of you getting up to this? Is it clear? Okay. So that means the lambda is calculated, x3 and y3 is calculated, and finally I am getting 3p, that is x3 y3. This point that I am getting, that is 10, 7. So the meaning is that when the curve is given and the point is given to you, if you want to calculate the 3p, so first of all you have to calculate the 2p, okay, where p equals to q. Okay, case number 2 is applied, and based on that you have to calculate the 2p. Once you calculate the 2p, then after what you have to do? The 2p plus p. That means here the case number 1 is applied, and based on that you have to calculate the 3p. So in this way you can calculate all this steps. Right? So up till now, what you have learned, how to find the, the curve is given to you and the question is find out the number of points on a curve. How to find the number of points on a curve, how to generate. So for that, one of the algorithm that I have explained. Right now, the points on a curve that you are getting, after that, the next step that we have discussed, how to perform the operation on the points on a curve. Okay, so when you apply operation on a points on a curve, then you get the another point on a curve, right? So for that, the three cases that I have discussed, that is P not equals to Q, P equals to Q, and the third case, right? So all of you know that I am not repeating that thing. So all these three cases that I have discussed, and then after, based on all these three cases, we have discussed the example. Okay, so up till now we have done this thing. Okay, so is there any doubt up to this three lectures? If you have any doubt, then please ask me, everyone, because next I will explain you the algorithm, ECC algorithm. Now next I will see, all of you know the algamal crypto system that I have discussed. Now today I will discuss the ECC curve cryptography simulating the algamal crypto system using the elliptical curve. Okay, so let me show you. Okay, so see everyone. Now see here I have written the key here, the three in this crypto system, the ECC simulating algamal, that is the ECC algamal crypto system. So in that, the three part that I will discuss, that is key generation, encryption and decryption. So the same concept, see the same scenario that in each and every lecture I am discussing. Here you have to assume that the allies want to send a message to a Bob. Then who perform the key generation? The Bob perform the key generation. And once Bob perform the key generation, so Bob side the two keys are generated, public key and private key. Okay, now once a public key and private key is generated, so now what the allies will do? So allies have some plain text, right? So with the help of the whatever the key, public key is generated by Bob, so that is send it to the allies. Now what the allies will do? The allies use the public key that is sent by what Bob. So with the help of that, the allies encrypt the message. So that means you can say that the ciphertexts are generated. Once the ciphertexts are generated, now it is sent it to the Bob, and what the Bob will do? The Bob have a private key, right? So with the help of the private key, again Bob decrypt it, and finally Bob get the original message. So this is the scenario, right? That you have to remember, right? So the first, that is key generation part. So that is performed by Bob because allies want to send a message to a Bob. So now see in exam, see the reverse question that I have asked. See the two in the first internal, the two questions that I have asked. In first scenario, allies send a message to a Bob, and the another scenario that I have discussed where Bob wants to send a message to allies. So most of the students have attended this approach. Allies wants to send a message to a Bob. Or most of the students have not. I think one or two students have attended that question. That is, Bob wants to send a message to allies. Otherwise, see the scenario is same. Okay. So now, first of all, what is the first step of key generation? So the Bob chooses the EPAB with an elliptic curve over a what? Galois filled P. Okay. So first of all, the Bob chooses an elliptic curve. Okay, elliptic curve over you can say that the Galois filled P. Okay. Then after, what is the next point? That is, the Bob chooses a point on a curve. Let's say even is some point on a curve. And all of you know that, see, actually in your lab session, what you have to do, this type of curve is given to you, right? Now, all of you know that how to do the point generation. Okay, so first of all, you have to, for this particular curve, you have to generate some of the points. And after generating the points, what you have to do, any of the points on a curve that you have to choose. Okay, so in that way, in your lab session, you have to implement that thing. So first of all, you can say that the Bob chooses this EAB with an elliptic curve over that Galois filled P. Now then, after what the Bob will do, the Bob chooses a point on a curve. On this particular curve, Bob chooses a point. So some point on a curve that I am taking. Now then, after Bob chooses an integer d value. Now then, after, what the Bob will do? The calculate E2, that is equals to d multiply with E1. Okay. So this is the x2 y2. Okay, so see here you can say that each and every point, see it is a what, it is a point, here the point is used. Okay, so now uh, after this point, what happened? Here you can say that the public key is generated, that is E1, E2, and EP, and the private key, that is D. Again, I repeat everyone. So first of all, the Bob chooses this EAB with an electric curve over this Gauss field P. Now then after, the Bob chooses a point on a curve, right? So you have to find the different points, and any of the point you can choose as a E1. Okay, now then after select a D, and then after you have to use this formula E2, that is equals to D into E1. Okay, so that you are getting, that is x2 y2. So now finally what I am getting, so finally I am getting, finally the two keys are generated, that is two keys are generated, that is public key and private key, right? The public key and private key, these two keys are generated. uh, Up to this clear everyone in key generation part? Is there any doubt? Is there any doubt everyone? Can you hear me? Okay. Now, see here, this is a key generation part. So now what the Bob will do, Bob send the public key of Bob to allies. So now what the allies will do, the allies say encryption is say by allies, it is done. Let's say the plain text is M. So now select some random integer R. So here, like in the Algama crypto system, the two ciphertexts are generated. Same way here, the equation for ciphertext 1, you have to use this equation C1 equals to R into E1, and C2 that is equals to M plus R into E2. Okay, so by using this equation, finally the two ciphertexts are generated, that is C1 and C2. Okay, now once the two ciphertext C1 and C2 is generated, after that what happened? So now it is sending to the what, this ciphertext is sending to a Bob, right? So now what the Bob will do? So the Bob decrypt it with the help of what? With the help of the private key, the Bob decrypt it. So now there is a verification is given. So if I am using this equation C2 minus D cross C1, then how I am getting this M? Okay, so this is a verification that also I have written, that is C2 minus D into C1. Okay, so instead of C2, what can you write? M plus R into E2. M plus R into E2. So M plus R into E2 minus D multiply with C1. C1 that is R cross E1. C1 that is what? R cross E1. So now what I am getting here? M plus R into, what is the value of E2? What will be the value of E2? So all of you know that. See here. E2 that is equals to D into E1. Okay. So now instead of that, can I put here D into E1, right? So this 2 is cancelled. So what I'm getting? M plus 0. So finally I'm getting M. So all of you clear in decryption how I'm getting the plain text? Up to this clear everyone, key generation, encryption and decryption. Can I explain you a example next? Can you hear me? Okay, so listen everyone. So now in the key generation, now in the key generation part, what you have to do? So see, what is the first step of key generation? That first of all, you have to select any select any elliptic curve. So let's say, see, this is the first step, E1311 that I have taken. Now what is the next step? All of you know that in the key generation, the next step is the chooses a point on a curve. So now see, this type of elliptic curve is given. So first of all, in implementation of lab, what you have to do? You have to choose this type of curve. Okay. So now once you get this type of curve, now after that you have to generate some of the point for this curve, and from that any of the point you have to choose as a E1. Okay. So in that way you have to implement in your lab session. So once you after that, what is the d equals to 1 that initially that I have taken. Now all of you know that this is the formula E2 that is equals to d into E1. Okay, E2 that is equals to d into E1. So now see here the value of d, that is 4, multiply with E1, that is what, it's a point, that is 1 4. So it is which type of form? All of you know that it is 4 into P. This type of form is there for P. Yes or no? Where P is what? The point is 1 4. Right? So now all of you know that how to calculate the 4P. So already that I have calculated over here. So now see here in this example already that I have calculated. Let me show you. See the example number 3. So the same curve, same elliptic curve that I have taken, and the P equals to 1 4 that I have taken. Now what I want to calculate? I want to calculate the 4P. So first what I have to do? First I have to calculate the 2P, right, based on that. And once I get the 2P, so what I get? 8 12. Now once I get the 2P, so from that I get also 4P. So finally what I get the answer over here? So I get 4P that is equals to 11 11. So 4P that is equals to 11 11, where P is what? See here, the elliptic curve that is 1 1, and the P equals to 1 4 is given. So up to this clear everyone what I'm trying to say? Is it clear how to get this value? Hello? Can you hear me? Hello? Okay. So listen here in this case, what I'm doing here. So I know what is the curve, what is the point, and based on that earlier already that I have calculated. Otherwise, the same process that you have to do here over here. Okay. So finally, what I'm getting the answer 11 11. All of you know that. So now, what is my public key after this key generation step? My public key is what? E1. E1 equals to 1 comma 4. E2 that is equals to 11 11, and this is the curve, right? And so what is my private key? The private key d equals to 4, right? So now the public key and private key, these two keys are generated. Now see here, one of the thing that I have written, that is plain text M 12.5 belongs to this thing. Why I have written that thing? Abhi, can you explain me? Please unmute yourself. Can you hear me, Abhi?
Hello. Yes, ma'am.
So which point you have to take for plain text, Abhi?
12 and 5 is the point on elliptic curve 1 1.
Yes. So like basically, whenever you choose plain text, see in Algama crypto system, what simple basic Algama crypto system, we are taking a number, right? But here in a elliptic curve, we are taking a what point. So for plain text, you have to take a choose a that point which belongs to this curve. And for that, which method? By using that algorithm, you have to find out the points. First, you have to perform the point generation. And based on that, whatever the points are there for that curve, that you have to select. From that only that points you have to select. Is it clear, everyone? Is it clear? Right? So now see, now then after all of you know that in encryption, first of all take any plain text. Now here I have written the select random integer some r that you have to take. Now see the example over here. So what I'm taking here, plain text m equals to 12.5, right? That belongs to this curve. Now random integer, some random integer r equals to 1 I am taking. And all of you know that the two equation that is C1 that is equals to r into E1. So the value of r that is 1 multiply with what is the value of E1? So here you can say that 1 multiply by E1 and E1 is E1 that is equals to 1 4 is taken. And what about C2? C2 that is equals to M plus R into E2. Okay, so what is M? So M that is 12.5, right? Plus R that is 1 multiply with what is E2? E2 that already I am getting 11.11. Okay, so now what I am getting here 12.5 plus 11.11. Now what I have to do everyone? Can anyone tell me? This is the first point, this is the second point. Now in between the addition operation is there, right? So now which case is applied? Please write down in a chat window. Now I want to find C2. Okay. Now here the 2 points are given to me and in between the operation plus is there. So which case is applied? Quickly write down. Case number 1, right? So here you have to apply the case number 1, right? Because P not equals to Q. Okay. So now how to calculate the lambda? All of you know that y2 minus y1 divided by x2 minus x1. Okay. So when you apply this formula, then what you are getting? Lambda equals to 7. Now what is how to calculate x3? So that is lambda square minus x1 minus x2 module by 3. So when you put all this value, so what is my x1? My x1 is 12 and what is my x2? That is 11. So finally what I am getting, x3 equals to 0 that I am getting, right? X3 equals to 0 I am getting. Now then after what do you have to do? Y3. Y3 that is equals to lambda in bracket x1 minus x3 minus y1 module by 13. So what I'm getting here, y3 equals to 1, right? So finally here I can say that x3 y3 that is equals to 0 1, that is 0 1. Okay, so now C1 that I am getting, that is what? The C1 that I'm getting, that is 1 4, and for C2 what I'm getting here 0 1. So that means these are the two ciphertexts that are created. Okay, now once a ciphertext is created, all of you know that I send this ciphertext to a Bob. Now what the Bob will do? The Bob decrypt it with the help of its private key D. So now Bob uses this equation, right? That already that I have explained. So C2 minus D cross C1. So what is C2? C2 that is 0 1 minus what is the value of D? The private key that is 4 multiply with C1 that is 1 4. This is a 1 point and this is another point. Now then after what I have to do, all of you know that again this is a which type of formula? This is a sum point and here 4 multiply with point. And all of you know that already that I have calculated, that is if elliptic curve is E1311 and at that time if point is 1 4, then for 4p what I am getting the value already that I have calculated, that is 11 11. Right, all of you know that. Up to this clear everyone? Is there any doubt? Please reply. Hello, can you hear me? So here you are getting 11 11. So instead of that, can I write in this way 0 1 plus minus? So see, if it is negative, then all of you know that the add inverse of 11 11, right? The case number 3 that already that I have discussed. So what I'm getting 11 comma minus 11, and finally I'm getting the again the I'm applying the case number 1. right? The case number 1 that I am applying. So lambda that is equals to y2 minus y1 divided by x2 minus x1. So when I am applying that formula, so what I am getting, lambda equals to 6 that I am getting. Okay, and now once I am getting lambda equals to 6, then I'm using this equation x3 that is equals to lambda square minus x1 minus x2 modulo by 13, right? So finally, when I put the value, I am getting 12, and y3 that is equals to 5 I am getting, and finally the decrypted, that means 12 5 that I am getting. And all of you know that initially which plain text that I have taken, that is 12 5, and finally after the decryption, what I'm getting, the value of x3 y3, that is 12 5. Up to this clear? Anyone have a doubt? Please reply everyone. Is it clear to you all? ECC Algamal. So now see, in next lab, in your NIS, in next lab you have to implement that thing, that is ECC Algamal. First you have to perform the point generation. Okay, that step that you have to perform, and then after you have to perform this ECC Algamal. Okay. Now, just wait. Now, this additional exercise for you. If you want to note down, please note down everyone. You have to take this elliptic curve, create a few points over the curve, means that by using that algorithm, first of all, few points that you have to create. Now, then after you have to take E1 as a this value, D equals to 4, E2 as 1345. The plain text you have to take this. So now the question is, first of all, you have to encrypt them and decrypt the C1 and C2 to verify whether it is equals to M or not. Okay. Now, one of the issue that I want to discuss over here, that is the challenge is to map any arbitrary plain text to a point on an elliptic curve. What is the challenge? Because see, here you can say that for plain text, you can't choose any point. You have to choose a point on a elliptic curve only, right? So that is a challenge. The challenge is to map any arbitrary plain text to a point on an elliptic curve. So the allies need to find a one-to-one correspondence between the symbols and the points on the curve. So there is a one of the challenge is that is you can't take any point, right? You can only take a point on an elliptic curve. Okay. Now the security of ECC. So now see, here I can say that if knows R, then C can use this equation, that is M equals to C2 minus R into E2 to find M, right? All of you know this equation. But to know R, if if knows R, then C can use directly, if directly C can use this equation, right? Because the ciphertext is known, E2 is public, right? So if Eve knows R, then what happens? The Eve directly get the value of M. Okay. But to know R, okay, the Eve need to solve this equation, that is C1 equals to R into E1. Okay. So the question is, if Eve knows R, then directly use this equation. But to know this R value, Eve need to solve this equation. That is C1 equals to R into E1. See, the E1 is a public and this is a ciphertext point and this is some random integer. So given C1 E1, we need to get R, which is known as the elliptic curve logarithmic problem. And see, this type of discrete logarithmic problem that I have discussed earlier. But see, if R is very large, then this problem is very hard to solve. Okay. So here the second scenario that I have discussed, that is, if knows the value of D, then the C can use the M equals to C2 minus D cross C1 to find N. But to find D again needs to calculate this value E2 equals to D into E1, right? So these are the 2 points that are public. But see, to find out this D, again it's an elliptic curve log problem, and this is hard. Again, when this value is very large, then again this task become very tough. So for the same level of security, the or a computational effort, the modulus n can be smaller than that in RSA, right? So the ECC over Galois fill 2 raised to n with an n number of 160 bits can provide the same level of security as RSA with the n number of 1024 bits, right? So this thing that I have discussed, I think in a first lecture that I have discussed all this point. So there is a comparison between the algamal and ECC algamal is given. It uses a multiplicative group algamal. ECC algamal, it uses an elliptic group. All of you know that, right? Algamal that I have discussed as well as the ECC algamal that I have discussed. The second comparison, that is exponents are number in the multiplicative group. Here the two multiplier in this are the points on elliptic curve, right? All of you know that. The third point is private key is integer in both the case. And fourth point is secret number is chosen. Okay. Now the fifth point is exponentiation is used in the case of algamal, while here in the case of ECC algamal, the multiplication of point by a constant is used. Okay. Now the sixth point is the multiplicative inverse of the multiplicative group is used, while here in the case of ECC algamal, you can say that the additive inverse of a point is used. See, I am not discussing in detail because all this concept already that I have explained, so I am not going in detail. Okay, in the case of algamal, the exponentiation is comparatively more. Just wait. Exponentiation is comparatively more harder than multiplication, while here the calculation is usually easier because the multiplication is simpler. And the last difference between these two is finding inverse require an extended Euclidean algorithm. All of you know that. While here in the case of ECC algamal, the finding inverse of a point here is much simpler, right? So this is all about ECC algamal's system. Okay, now in next class, I will explain you Diffie-Hellman and ECC Diffie-Hellman. Okay, so thank you everyone. Is there any doubt up to this? So all the points that I have covered, how to generate the points, how to perform the operation on ECC, some of the examples that I have discussed, the ECC algamal crypto system in that I have discussed key generation, encryption, decryption, right? So all that parts that I have covered. Okay, so is there any doubt? Is it clear to you all in today's session? Okay, thank you everyone.